Hi there, welcome to Peppy's Civil class. Today's question is under fluid kinematics and dynamics. So let's read. Water flows in a circular pipe. At one section, the diameter is 0.3. Okay, we have diameter at A was part of the question, 0.3, and diameter at B to be 0.15. This was part of the question. So at one section, the diameter is 0.3 meters. Okay, 0.3 meters. Then the static pressure is 260 kilopascal gauge. So pressure at A is equal to 260 kpm. The velocity is 3 meters per second. So the velocity at A is equal to 3 meters per second. And the elevation is 10 meters above ground level. So the elevation here is equal to ZA. ZA is equal to 10 meters above ground level. And then the elevation at a section downstream. So downstream is the B part. We have 0 meters. So B, elevation at B is equal to 0 meters. And the pipe diameter is 0.15. So diameter at B is 0.15 meters. This is section A and section B. Find out the pressure gauge. Find out the gauge pressure at a downstream section. So we have to find PA. We have to find PB, which we don't know. Frictional effects may be neglected. Assume density of water to be 999 kilogram per meter cube. Okay, so let's start solving. Data given. All our data are like very clear, so we just pull them out. And since we have section A, the section A part and the section B part, let's group it. So section A of the circular pipe, we have the diameter to be 0.3 meters. So diameter at A is equal to 0.3 meters. What else do we have? The elevation at A. So ZA is equal to 10 meters. And then we have the gauge pressure at A, which is PA, is equal to 260 kilopascal. And then we have the velocity at A, VA, is equal to 3 meters per second. Okay, now section at B, the downstream. The downstream, we have the diameter of the smaller pipe, which is DB, is equal to 0.15 meters. And then we have the elevation ZB to be equal to 0 meters. And then we don't have the pressure at B, PB. That's what we are yet to find. And the velocity at B, we do not have the velocity at B. Okay, but we can find the velocity at B and whatever from the continuity equation. Okay, so from continuity equation, okay, we know that AA, the cross-sectional area at A, is equal to multiplied by the velocity at A is equal to the cross-sectional area at B multiplied by the velocity at B. Okay. And from this equation, we already have our diameters, so we can calculate for our areas, and we have the velocity at A already, so we make velocity at B the subject, then calculate for it. So making velocity at B the subject, okay, is velocity at B is equal to AA, cross-sectional area at A, divided by cross-sectional area at B multiplied by velocity at A. So now let's calculate for the velocity at B. Okay. So now VB is equal to AA divided by AB multiplied by VB. Sorry. No, we are calculating for VB. So VA. I hate to cancel. VB is equal to AA over AB multiplied by VA. Yes. Okay, so since we know the diameter at A and B, diameter at A is 0.3, diameter at B is 0.15. So A pi over 4 multiplied by diameter at A squared pi over 4 multiplied by diameter at B squared multiplied by VA. Okay, now we have D A squared divided by D B squared multiplied by VA. DA 0.3, DB 0.15, 0.3 divided by 0.15 all squared multiplied by VA. 3 meter per second. Okay, this one. 3. So this will give us 12 meter per second. Okay, which is VB. Okay, so now we know VB to be 12 meter per second. Let me write it here. So we also have we have to calculate for the weight. Weight was given how do you call it? Density of water. So density of water was given as 999 kilogram per meter cube. So use the density of water to calculate for the weight. Okay, so weight is equal to density by gravity, right? So 999 multiplied by 9.81 gravity, and this will give us 9800.19 Newton per meter cube. Okay, since we have this one, we can go ahead and calculate for gauge pressure at B, this one, and we will be needing the Bernoulli's equation. So from Bernoulli's equation, okay, we have to we have PA divided by W, weight, plus velocity at A squared divided by 2 multiplied by gravity plus elevation at A. So it's equal to the gauge pressure at B divided by the weight plus velocity at B squared divided by 2 gravity plus elevation at B. So the A part and the B part. Okay. So pressure gauge at A, PA 260 kilopascal. So 260 multiplied by 1000 divided by the weight. We have 9800.19. Okay. Plus velocity at A, VA 3 meter per second. So 3 divided by, so 3 squared divided by 2 multiplied by gravity 9.81 plus ZA was 10 meters. Okay. Is equal to PB. We don't know PB. That is what we are yet to find. Divided by the weight 9800.19 plus velocity at B 12 meter per second. So 12 squared 2 by 9.81 plus elevation at B was given as 0. So we sum up all this, then we make PB the subject, then we get our final answer for PB. Okay. So this whole expression, okay, if you multiply this one, you do the summation of this one well, we are going to have 36.989. Okay, is equal to, now we come to this part. This part we have PB over 9800.19 plus this alone will also give us 7.34. Okay, so we make PB the subject. So PB dividing 9800.19 is equal to 36.989 minus 7.34. Right. Lots of new sheets. Okay, so we're continuing from here. Right. So now PB divided by 9800.19 is equal to 29. 36 minus 7. We have 29.649. Now straightforward, we multiply this and this. So PB is equal to 29.649 multiplied by 9800.19, and this will give us PB to be 290.56 kilopascal. Okay, so if we write that here, PB is going to be 290.56 kilopascal.